For this lesson, we're going to be talking about factoring again, but we're talking about factoring what we call special cases. And special cases are just kind of, they're tricks of, there's two particular types of problems that are really easy to factor. And so we learn how to do those because it just makes our life easier. The first one is called the difference of squares. So when you think about the word difference in math, it should, in your head, you should think, oh, that means to subtract. So what the difference of squares means is the subtracting of, so the difference of squares. Now, squares in math does not mean a four-sided shape, or, well, it can mean a four-sided shape that all sides are equal, but that's not what it means in this particular case. When they're talking about the squares in this case, they're talking about perfect squares. So, for example, 25 is a perfect square because it is the same thing as 5 squared. 49 is a perfect square because it is 7 squared. So that's the kind of squares they're talking about. So the difference of squares is subtracting of two perfect squares. And that's what we call these numbers that are in fact perfect squares, like 49 and 7, or 49 and 25. So the rule for these is actually really quite simple. It says for any two values or expressions a and b, a squared minus b squared. So notice this is a perfect square because a squared is the same thing as a times a. And this is a perfect square because b squared is the same thing as b times b. And most important thing is that there is a minus sign here in the middle. When we factor this, it is simply a minus b and a plus b. That's really all it is. A minus b times a plus b. So they've given you an example over here. And I don't particularly like this example, but it's okay. We'll deal with it. We have 4x squared. Well, 4x squared, we've got to figure out, is that a perfect square? Well, 4 is the same thing as 2 times 2, or 2 squared. And obviously, x squared is a perfect square. And 16 is the same thing as 4 squared. And they've written all this out down here. That's what all of this says. And it is a subtraction sign in the middle, which is what it's supposed to be. So that means when we go to factor it, we can write this as 2x minus 4 and 2x plus 4. So all we did was we took the square root of the first number. So 4x squared, the square root of that was 2x. We put a 2x in each one. We took the square root of 16, which was 4. We put a 4 in each one. And we put a plus and a minus sign. So they've given us a couple of other examples down here. And they've actually done several, the first one for us. So the first one was x squared minus 9. We're going to talk through this, kind of ignore the steps that they've gone through. Well, x squared is a perfect square. 9 is a perfect square because 9 is the same thing as 3 squared. So that means I can write this as x minus and x plus 3. And so those are our factors, x minus 3 times x plus 3. And that's what they have over here. They do have it written the other way, x plus 3 times x minus 3, but it really does not matter which parentheses comes first. So for the second one, we have x squared minus 25. Well, x squared is a perfect square. 25 is really 5 squared. So that means I can write this as x minus 5 times x plus 5. We already did 4x squared minus 16. That was the example we got up here. And so we know the answer to that is 2x minus 4 times 2x plus 4. This last one is a little bit tricky because it's just all letters. But if you'll notice, every single piece here is a squared term. And as long as they're all squared terms, then we're good to go. So we would just take from this first part, x squared minus x squared y squared, we're going to take in each parentheses and put an x and a y and an x and a y. And then for the z squared, we're going to put a z in each parentheses. And then, as before, we put a plus sign in one and a minus sign in the other. It doesn't matter what order it is. Now, the important thing I will tell you with difference of perfect squares that you have to remember, and you may want to make a note of this so that you don't forget, and I'm actually going to write this in a different color. So I'm going to do this in an orange color, is that it only works if there is a subtraction sign. Okay? Now what this means is that they're going to try and trick you because, you know, they have to be mean in math. And so I'm going to write an example up here of something that would not work. So for example, what you could not have is x squared plus 49. Yes, it has two terms. Yes, they're both perfect squares, but because this has a plus sign in it, it cannot be factored, and something in math that cannot be factored is prime. Okay, so this only works if there is a minus sign in the middle. So moving down to the next part is what's called a perfect square trinomial. Okay, so perfect square, we talked about that, whereas where like 25 was a perfect square because it's the same thing as 5 times 5. So what it means to be a perfect square trinomial, I'm going to go ahead and go on the next page, is that the factors, the two factors, let me be more specific, of the trinomial are the same. The two factors of the trinomial are the same. So there's huge long rules about this, and I'm going to talk about the rules, this part right here, and then I'm going to explain what that really looks like because, you know, it's actually much easier than it appears to be. So the rule says that if you have an expression such as a squared plus 2ab plus b squared, then it can be factored into a plus b squared. And the same thing is true if it's subtracted, it would be a minus b squared. I'm just going to tell you how to figure it out because it's actually much easier than this. But I wanted to make sure you had this in case it asked for that on the quiz. So here's what you look at. You look at this trinomial right here. First of all, it's a trinomial, so that's a good thing. Okay, the second thing we have to do is we're going to see if it's a perfect square trinomial. I'm going to divide the middle number by 2 and see what I get. Well, 8 divided by 2 is going to give me 4. I'm also going to take the square root of the last number, and the square root of the last number is also 4. So since this number and this number were the same, that means this is a perfect square trinomial. That's how it works. So when I go to factor it, it's really easy. I put an x, I take whatever sign I have right here, and I put that there, and then whatever this number was here, whatever it was, doesn't matter. I take this number, and I put it in the end. And then I'm going to add a squared sign on the end. Because we said the two factors of the trinomial are the same, so there has to be two factors. If I put a squared sign there like I did here, what that means is my factors are really x plus 4 and x plus 4. And instead of writing it twice, I can write it as x plus 4 squared. So let's check the next one. Okay, it says x squared minus 12x plus 36. So we're going to do the same thing we did before. We're going to take each of these numbers, or we're going to take the middle one, and we're going to divide it by 2. Well, 12 divided by 2 is going to give me 6. Don't worry about the sign right now. And then I'm going to take the square root of 36, and the square root of 36 is 6. So since these two numbers were the same, this is a perfect square trinomial. So that means my parentheses is going to be x. I'm going to bring this sign, whatever it is, in here, minus. And then whatever this number was, 6. And then I'm going to square it. So my factor in this case is x minus 6 squared. So there's some rules that go along with this, just some guides for you. In order for it to be a perfect square trinomial, the first thing that has to be true is it has to have exactly 3 terms. The second rule is the first and the last term must be perfect squares. The third thing is the perfect squares must be positive. If we look back at these 2 examples, notice that I'm going to do this in a different color here. Let's do this in a lime green. Notice that that's not what I wanted to do. Notice that this was positive and this was positive, and this was positive and this was positive. It didn't matter about the middle part, but the other ones all had to be positive. Okay? And then the fourth rule is that the x term must be 2 times the square root of the perfect square. So that's where we get the divided by 2 part in the square root to make sure they work. Alright, so let's do example 1 here, problem 1. So I'm going to check to see if this is a perfect square trinomial. And I notice that this is positive and this is positive, so that's 2 good signs. So I'm going to divide this one by 2, and I get 1. I'm going to take the square root of 1, and I get 1. So they're the same numbers, so that means this will work. So my factor is going to be x plus, and that plus sign happened because there was a plus sign right there, 1 squared. And that would be my answer. So we're going to do one last one. So we have x squared minus 4x plus 4. I'm going to divide 4 by 2 and I get 2. I'm going to take the square root of 4 and I get 2. And since both of them gave me 2, I know this is a perfect square trinomial, so I'm going to do my parentheses. I'm going to have x minus this time, and that minus sign again came from there. And then 2 and squared, and that would be my answer. So we're going to look at the checkup, and we're going to do the odds. So number 1, I have x squared minus 25. Well, this has 2 terms, and I need to see if both those are perfect squares, and x squared is x times x, 25 is 5 times 5. So that means to factor this, all I have to do is 2 parentheses, x minus 5, x plus 5. Again, that was possible because 25 is really 5 squared. Number 3, I have x squared minus 100. So x squared is a perfect square. 100 is really 10 squared. So I can factor this as x minus 10, x plus 10. Number 5, we've actually already done this one, so I'm going to skip that. And number 7, I have 4x squared minus 16y squared. This one's a little trickier because I have, letters in both parts and numbers in both parts. So we've got to make sure everything's a perfect square. Well, 4 is really 2 times 2, so 2 squared x squared. Minus 16 is really 4 times 4, so 4 squared y squared. So everything is a perfect square. So when I go to factor it, I have a 2x and a 2x. I have a 4y and a 4y. I'm basically just taking one of each of these and putting them in the parentheses. So I'm taking 1, 2, and 1x and putting it in the first one. The other 2 and the other x go in the second one. And then my signs, one's positive and one's negative. All right, number 9 says, for what value in place of the question mark makes the polynomial a perfect square trinomial? So this one's a little bit trickier. You've got to actually figure out what the number is that's missing. So remember, the deal is that when I divide the middle number by 2 and I take the square root of the last number, I should get the same thing. So 30 divided by 2 is 15. So I've got to figure out the square root of what number equals 15. Well, the easiest way to figure that out is to do the opposite of square root, which is to square. So I'm going to do 15 squared, and 15 squared is 225, so that would be my missing number. Since we didn't do a perfect square trinomial, I am going to go back and do problem 6. It says x squared minus 14x plus 49. We want to see if it's a perfect square trinomial, so we're going to divide 14 by 2 and take the square root of 49. 14 divided by 2 is 7. The square root of 49 is 7. So this is a perfect square trinomial. So that means my factor is going to be x, I bring down this sign, minus 7 squared. And that would be my final answer.